Let's do it. What's up, everyone? So we're going live here a few minutes early. That's all good. Let me know if you can hear me with a little shout out in the chat. Hey, I was just getting this model ready. I like you guys so much. I'm going to disassemble this prototype so we can look at the parts individually. All right, thanks for letting me know you can hear me, guys. I'm taking this bad boy apart here, so, give me a sec. There's a lot of pieces. I forgot there's so much hardware in this thing. Hey Hassan, what's up, man? Easy wall mount design. Yeah, it's not too bad at all. We're gonna go through a couple pieces today, and hopefully you'll learn something. I actually have a whole page of pro tips I want to give you, so I hope it's very educational. Also, hopefully a little entertaining as well as we go through. I still got 2 minutes, so don't rush me into my modeling. I gotta take this apart. This is one of the parts we're gonna do today. Looks kind of simple, but there's a couple contours, and I want to talk about how we're going to capture this design intent in the best way. So that'll be one piece we do. What's up, everyone? Hey, thanks for joining. Give me 1 minute. Hit the top of the hour before we get into the CAD stuff. Right now, I'm just disassembling this prototype. It's gonna be a pain in the butt to put back together, but whatever. It's worth it for y'all. How's everybody doing today? Happy Friday. There's the top of the hour. Hey. Hey, Oscar. Yeah. I don't know if I said that right. Yes, sir. We will be recording these. We'll have a whole playlist of these. So definitely stick around. All right. Hey, everyone. Thank you so much for being here. Looks like it's the top of the hour. Big shout out to our friends in the SOLIDWORKS brand team for putting together this stream session and for having me host the second one. If you guys saw Monday we had Toby model this SOLIDWORKS certified expert mug. So Toby, cheers. Thanks for passing me the mug. A little bit cold from this morning, but if you guys missed out on his stream, it was actually really educational, learning about lofts and the Pierce relationship, so important. So make sure you check out the recording after this, though. So these will all be recorded. They'll all be available on the playlist. So let me know in the chat. Were you guys here Monday? Did you see Toby? If so, what did you think? Kind of some big shoes to fill. Also in the chat, let me know where you're from. We had a lot of great international folks. I'm in Chicago, so a lot of folks from all over the world on Monday. So super excited to see where y'all from today. All right. So today we have some really exciting stuff. I have a whole page of tips that I want to show you. And after this is done in the recording, I'll put up the list of these into the comments of the video, as well as in the SOLIDWORKS forum, so you can follow along. Bulgaria, Portugal. What's up, Nuno? Anyone from further away from me than Bulgaria? Hungary, Croatia. Jordan, there you go. My coworker Jordan, he's here. He's the Croatian guy as well. Follow the mug, excellent. Sweet, glad to have you guys back. All right, so I only have an hour, and my goal is to get through 2 different pieces. I hope I do. So the first one we're gonna do is this arm piece, and you can see, let me switch to my screen. You can see if you saw the promotional renderings that this is the design that I want to talk about. And this is an oldie but goodie. You know, we designed this a few years back, got it rapid prototyped, got everything printed. It never made it into production, and I'll talk about that at the end. And maybe some of you mechanical engineers are already seen a few reasons why. The goal of this monitor arm was to support kind of your bigger format monitor. You'll notice it's a VESA 200mm mounting pattern. So it's not your typical 100 by 100 that goes in the back of a computer monitor. This is really meant to be all aluminum and support 150 pounds of like a big touch screen. So we're gonna model the arm piece today. Then I'm gonna get into this red piece, which is sheet metal. We'll talk about some sheet metal best practices. We'll probably run out of time. I gotta watch the clock here. Let me know what you guys think as we go. I'll be watching the chat. If you want me to discuss something or revisit something, let me know. I'm gonna hopefully do this in a way that you can follow along. So I'll be starting with a blank part, and it might be hard to follow along real time. So maybe just sit back, watch, and enjoy. And then if you want to do it again, do it yourself. You know, maybe watch the recording so you can pause and maybe take it on a tangent on your own. All right, sound good? So let's get going with the arm piece here. I'm going to start a new part from my millimeters template. Anyone object to millimeters? What's up, everyone? Alpha Centauri. Hey, Mondo. Okay, so blank, brand new part. And, of course, we all know the first decision you got to make is where do you want to put your first sketch? Actually, you got to decide what your primary feature is going to be. I'm going to turn on all the primary planes because I want to understand, what the orientation is going to be. And if you look at this piece, from each angle, which is the predominant shape? Where do you want to start with? And for me, from the concept design, actually, I know that this kind of dog bone shape, 30mm bosses for the holes, and this dog bone middle spar here, that's going to be my primary shape. So I'm going to start with that, then sculpt it to this shape, add in the middle cuts, and then we'll go back and make sure that we have all these features where the bearings and fasteners go. Hassan, pretty easy. Yes, sir. Not that complicated, but I'm going to give you, I have 12 tips as I model this. So hopefully, Hassan, you're thinking about how you would model it. And there's no right or wrong way, right? It's about how you capture your design intent, where you're going to start, and then probably how robust your model is if I decide to make changes. So by the end, I want to create the model in such a way that I can make it taller, skinnier, and adjust it, but then not have all my downstream features break. Okay, so I'm going to keep that in mind. So with that, I'm going to start on my top plane and start a sketch. Using my in-context toolbar, go normal 2. And if you think about this profile, you can see it's symmetrical about its midplane, going horizontally. So what I'm going to do is use the origin as the midpoint there. My planes are kind of in the way, so, get comfortable. There's a heads-up view toolbar to turn on and off certain things. I'll be using it a few times. Hide and show the planes. S key, shortcut bar, right? Instead of going up into that top left for all the sketch tools, put your stuff on your S key. Big fan of the center point rectangle. That helps me maintain this thing that's going to be centered. So it's going to draw out the dog bone, going to grab a circle, go with the midpoint, snap to that. And this is a feature I really like. Auto scale to the first dimension. So I haven't dimensioned anything, but I know I have the rough shape down. And whatever I apply the first dimension to be, 30mm, it's going to scale the whole thing. So I'm going to use that on the next part as well if you missed that. Let's apply a quick equal relationship. One of the things you'll see me do a lot in SOLIDWORKS is a pre-select and then command. So for example, if I select with holding control, the 2 arcs, I get the pop-up indicating what I can do with it. We'll make those equal, and then I'll throw in a few more dimensions. Easy enough, right? There's nothing complicated about that. Let's extrude this. And again, it's not so much symmetrical about the top plane, but I like to do a mid plane anyway, because I probably could keep some design intent going both directions. Now, since it's not one continuous open contour, I'm going to use the selected contours and use my profiles. Now, there's a couple ways you could go from here. I could actually do a trim and get rid of all the stuff in the middle so it is just one continuous region, but I don't want to do that, and you'll see why in a moment. Also, it would get rid of all my reference geometry. All right, and this is kind of my block, if you will, that I'm going to start from. So let's make that 50 millimeters. Let's throw on a fillet to round this off. Oh, let me show you this. This is so cool. So if you select an edge, and you know I kind of want to get all four of those, it's a little selection pop-up, the edge selection helper. We'll just go ahead and use that. Super easy, right? All right, let's go on to my my front plane, and let's create these arc shapes that kind of are the master industrial part, if you will. Checking my comments here. How's everybody doing? Great, loving SOLIDWORKS. Yes, you can. Awesome. Hey, everyone. Thank you for being here so much. It's great. All right, so I'm going to start a sketch on my front plane. I'm going to go normal 2, and let's start our sketches. Now, functionally, it's actually flat here because this mounts into the arm here, as well as it's mirrored underneath and fits into the back bracket. So I need this part to be flat, but then notice I got this nice curve that comes down here and down here, and that gives it a nice shape as it comes together at the joint there. This is just 4 of the exact same arms that we just turned upside down. So I'll make it super simple. All right, so I'm gonna grab a sketch, and I'm gonna make sure and grab this edge here. Notice how it's gonna snap to that top edge, straight line, and then I wanna turn into a tangent arc. Again, hopefully you guys know, if you're in the line command, just go back over that point, and it'll turn into a tangent arc. Pretty slick. All right, same thing down here. Straight line, right? So move the mouse back over that point, come off of there, tangent arc, easy enough, right? S key, dimension. 30, that's gonna be the diameter of my main boss. And again, you can see these sketch relationships, right? These are sketch relationships. Get to know these because they help you verify that, oh yeah, those are tangent or it is horizontal. And SOLIDWORKS picks those up automatically, but you just want to make sure as you fully define your sketch, look for those. You don't want this arc hinging at a weird angle. All right, let's throw a little radius on here just to fully define it for all you folks following around at home. Let's do 600. Just make these both 600. I think that should be pretty equal. There we go, and extend this out. And notice as I drag, and if you guys are new to SOLIDWORKS, we always teach this in like the first day, but notice I have a blue line and a black line. Black line is defined, blue line is underdefined. So I can drag this and see where that degree of freedom is. Obviously, it's in the vertical. And that's a pretty big important design dimension. It's kind of my second most important, because remember, that's going to drive how it fits into these mating brackets. So I'm going to start, I think 35, but you know, we can always come back and change that later. These endpoints are not defined, but I'm just going to kind of go across here and make sure that they extend past my model. That's as simple as I'm going to do, because this is, again, it's the very first sketch. I'm trying to capture as much of the overall bulk cutting as I can in the first couple sketches and features. So let's turn this into a cut. And you'll notice right away, if you have 2 or more open contours, SOLIDWORKS will think it's a thin feature, meaning it's going to automatically add a thickness. And I don't necessarily want to do that. I want to use basically a surface to slice the model and cut off the top and bottom. But I have to use 2 cuts to do that. Selected contours, get this top piece, flip the arrow to cut this side away, and I'm going to through all both. So that's a nice tip. Instead of trying to make this weird big cutting shape, you can always cut with a single open contour like that, just kind of like a slicing tool. All right, and then I can go back into my sketch, pick that up again, extrude cut. Let's grab the contour, grab this here. Do not want to do a thin feature. Through all both. Make sure I got the right end to cut with that arrow. Easy enough, right? Now you'll notice I'm kind of missing something here. I did this cut, but I lost my boss face here. So what I'm going to do is go to my boss extrude, go back to that first sketch, and I'm going to borrow it for this downstream extrude. And that's why I didn't want to necessarily blow away these contours. I wanted to maintain this shape so I could bring it forward. And let's bring 30 millimeters. Easy enough, right? Save it. Probably a good time to save it. Let's call this arm in progress live. Don't mess it up from here. How's everybody doing anyway? Why are you not constraining your sketch points to the top plane sketch circle quadrant? Yes, good question. I agree. That's a good tip. You could definitely sketch it that way or constrain it that way. I like it. Great. Keep the tips coming. Okay, so with this in mind, I want to show you something that you guys probably know this, but let's go over to the feature tree real quick. And you notice this icon, this hand with the region select? This says that it's a shared sketch. And you think about this, if you're modeling something and you're using kind of one or a couple different kind of master sketches to drive it, you're going to get a lot of these shared sketches. So let me show you how you can organize your part a little bit better in order to keep that organized. So first of all, when I'm going to use a lot of shared sketches, I like to go to my tree display and show a flat tree view, because it's really annoying to figure out, expand all the features and see which of the, sketches were absorbed into there. So a flat tree view, if I flip to that, it shows me everything without nesting them. And then I can start renaming it, right? Toby talked about that last week. Top dog bone, side arcs. There we go. Now I have it very easily exposed, kind of these master driving sketches, right? Easy enough. And I should go through and, name these. I'm not going to do it right now, though. So with that in mind, we got the shape. Great. This little cutout, it's a nested cutout. I don't know how well you can see with the lighting here. All right, and I'm going to use the offset entities command to create this shape. So I'm going to start a sketch on the right plane. Again, I'm going to use planes and the symmetry as much as possible, and then cut from the planes. And that's hopefully going to add robustness to my model if I change a face downstream or anything like that. Start a sketch. I'm going to select this face. I'm going to offset entities. Since it's a face, it's going to kind of take the whole perimeter and offset that for me. And you can see the yellow preview. Let's try 6 millimeters. Oops, wrong direction. Slow down. There we go, 6 millimeters. Adds a dimension, we can change that later. I really like this. So you can tell it's all black, it's all constrained. This sketch relationship there is a offset entities, right? So again, learn your sketch relationships, it'll be really helpful. I'm gonna go ahead and delete these. I don't want perpendicular edges, but I do want to borrow these curves without having to re-sketch them. Then if I go back and change that radius that we used for the top cut, it'll be reflected downstream. So what I'm going to do is drag these, and I really like that. Notice that it'll take the curve, it'll take the edge, and allow me to extend it freely. So I'm going to give it a little more aggressive shape. Drag those endpoints. And notice the endpoints are blue because they're not defined where they start or stop, but the black line is defined because it's offset from the edge. Drinking coffee. Hey, cheers. SOLIDWORKS 2020, yep. Hey, Gian. What's up, Mondo? Herstick, yeah. Blackjack. You guys seen that 21 show? That's pretty good. You guys saw Toby model this thing, right? Man, a lot of stuff that I thought would be simple, but especially that loft. It's good stuff. All right, let's continue on the design here. S key, I'm going to grab my 3-point arc and close this up. And you'll notice I got to go back and add some sketch relationships. It's not snapping to tangency. And this is where you got to watch your relationships. I don't have tangency here, and I need that. Select just the point, and I can use the pop-up in-context toolbar, make tangent. Same thing down here, make tangent. I like that. I want these to be equal. That's my design intent. So Control select both of them. Equal makes the arcs equal radius. And then so I have a design dimension that I can use later. I'm gonna put in a 25 there, right? And there's the beginning of that shape. Let's also, well, actually, let's move these in a little bit. I don't want it to interfere with the eventual counterbore that I need to do for the hardware. So let's make sure it doesn't extend too much. I guess, you know what, you're right. Yep, good point. Let's fully define that. So where this cut starts, I'm going to throw a dimension in just to fully define it. The great thing about adding dimensions like this, even if I don't necessarily know what the value is that later downstream, I can use Instant 3D to nudge them and see the results. So I'll do that as we get towards the end of this model. Fully defined, and the last thing I want to do, though, is add a sketch fillet and round off these edges. That's a little aggressive. Let's go down to, let's see, 3 maybe? 3, 4. That looks okay. All right, still fully defined, and look at all those sketch relationships coming up. Okie dokie. Okay. Control save. Exit my sketch. So now remember, I have this sketch on the midplane. And actually what's happening here, you can't really see it, but it's kind of making this I-beam type shape. So the first pocket leaves some thickness, and there's a second cut that actually goes through all. So what I'm going to do is extrude cut. And I really wanted to show this. I think it's something that I always forget about because I don't do it so much. But under the from condition, let's scoot this bad boy over here. You can offset the from. Okay, so let's offset, let's say 4 millimeters from the sketch plane to start it. And we'll do a through all condition. Easy enough. Mirror to the other side. Again, pre-select stuff. Get comfortable. I use my pinky for the control select. I don't know if there's a better way to do it, or to remap control maybe to the mouse button. I've never tried it. Let me know in the chat if you guys have remapped control, because I use it all the time. I'm always selecting multiple things, then invoking a command. So for example, the cut, the front plane, control select that, bring up my S key or wherever, go up to the command manager, mirror those over, mouse gesture up, okay. Easy enough. Let's start a sketch on this face. Actually, you're right. I was doing it this way. On the front plane, let's sketch it there. Take this shape, offset that, reverse that. Looks pretty good. Fully defined by the virtue of the offset. Let's extrude cut. Right click to get to my end conditions. Through all both directions. Right click OK. Not too bad. I'm going to throw a fillet. I didn't want to do a sketch fillet in this case because the way it's offset as I moved it, the sketch fillet basically either gets destroyed or created depending on how much I offset it. So you can see that SOLIDWORKS automatically offset this curve as it went in to just a point-to-point relationship, and that's awesome. And that's why I have to go back and basically apply the fillet to the edge at this point. Shoot that edge. All right, sweet, looking good. Let's apply a 3D. Yeah, let's do the counterbore at this point. Okay, so back to the model. You can see there's an M8, M6. Actually, forget which one this is. Which bolt is this? Tell me which one. Is this an M8? Little shoulder bolt? You guys tell me. Anyway, there's a through all condition, but there's also a bearing and a bushing here that connects that. So I want to do a counterbore cut. And I'm going to do a hole wizard because it has all the sizes in there for me. And notice I didn't select a plane or anything. So if you don't have a planar surface pre-selected, SOLIDWORKS hole wizard gives you the option to do a 3D sketch. And I really like this because it lets me get both of those in one feature. All right, so I'm going to go down here. I'm going to wake up the center point by mousing over the perimeter, grabbing that. And notice it'll do normal to the surface. I think that's in the CSWE somewhere. All right, but it'll start at the point, normal direction to the surface, and I woke up the center point, so it should be fully defined. M8 actually looks about right. M6. Thank you, sir. What else is going on in the chat? Let me know, guys, if you have any questions. What's going on? Nuno. Yes, Nuno. There'll be one on Monday as well. Andy Barnes will be joining us with a pretty good surface model. Okay, so let's apply the kind of the finishing fillets, the cosmetic ones. I like to save that for the end because they're the things that like to break. Or break downstream features as I adjust the size or adjust the order of my fillets. So I don't want to be referencing things off of the fillet edge, for example. So I wanted to make sure and get my hole wizard off of this, kind of hard surface, if you will, that we created at the very, very first feature, because that probably won't change, but these fillets may. Check this out. If you guys don't know about this, I love this in the fillet manager. We want some 1mm fillets kind of over everything. And when I click, I get this edge selection pop-up. And as you go to the right, it kind of extends it in different ways. And it explains it to you. But what do I want? Something like that, maybe? It's pretty good. Get these inside one. So obviously a real time saver when it comes to picking all these edges. Pretty good. I didn't select the one. There was an option in the very beginning that would have selected all edges, but it was a little too aggressive. You know, it was getting some of these drill holes as well. So you can see I have the full preview option on over here on the left-hand side of my property manager. And this is a good performance tip. This will remember your last setting. So I usually have partial or no preview on for a more complex part, because as you select like hundreds of edges, it'll take forever just to generate the graphics. So make sure if it's really taking forever, you don't have this enabled. All right, mouse gesture upright. Okay, Control S to save. And that's looking pretty good. By the way, so S key, we all know about that. I'm hitting S as in snake on my keyboard. I also have my mouse gesture configured. And we talk about this a lot, but I want to share what I do, because I think this is an easy way to use it. It's realistic. So here's my mouse gestures. And you'll notice that I keep them very consistent across all of them. So this mouse gesture is when you do your right mouse and you kind of move your mouse in one of the cardinal directions. And there's a different mouse gesture that you can configure for part sketch assemblies and drawings. Now I could never keep those straight. So what I do is I keep them consistent. So my mouse up is actually my shortcut bar. So check this out. My S key, shortcut bar is its formal name, Mr. Shortcut Bar. Drag and drop that. You'll also notice against all these mouse gestures, I have OK as my kind of northeast quadrant. Escape is my back left. And you can configure from there. Normal 2 is mouse down. So what's the point of all that? Well, I have that configured. And now I can, in any instance, you know, let's go normal 2. So, you know, I'm going around here. I want to come back to this sketch. Normal 2. Mouse up, there's my S key. Mouse up, there's my S key. So kind of a workflow. Let's see. Pick a face, start a sketch, mouse up, grab a feature, etc. Mouse up, grab your dimension bar. All right, so the thing that I'm looking at here, you can see this part. Let's put it that way. This way? There you go. It's actually a little bit more skinny. So I want to talk about the design intent that I captured. And hold on. Let me rename a few things. So I have a sketch, which is my master first feature, my top dog bone. Got my side arcs. I'm going to rename these sketches so I'll remember what the heck they are later. And this is my second through all. And this is really nice, especially if you're working with other folks here. This a little bit. If you're working with other folks, is make a favorites folder of the master design dimensions or features or sketches. And what I mean by that is I'm going to grab these 4 sketches that kind of define the entire shape of what I'm doing here. I'm going to right click on them and I'm going to add them to favorites. And then there's a lot of different ways to use favorites, but I like this because now if I come back into this part months, years later, I can look at my favorites and understand that these are kind of the main things defining this shape. I don't have to dig through the tree. And of course, I could rename these as well. So now that I've done that, notice when I click on one of these sketches, I get a bunch of the dimensions, the sketch dimensions showing. And there's a little blue ball at the end of each of these, and I can drag that. That's because I have this turned on up here, Instant 3D. So keep in mind that you can turn it off, kind of a safety, if you will, so I don't drag dimensions around. But if I turn it on, it'll expose the dimensions and allow me to drag them. So, for example, let's go normal 2, and let's take this 35. And remember the way I designed it with the offset allows me to manipulate this, and it should stay pretty good. So let's grab that. Let's take that boss here. Let's shorten that a little bit. This offset kind of got a little wonky, so let's take that second through all, maybe reduce that offset a little bit. Right? Easy enough. So Instant 3D, pretty cool. And you can imagine sitting there with your team or just kind of mucking around, seeing what's going to look the best. All right, so I'm going to pause there, see what's going on in the chat. How's the weather in Chicago? It is okay. It's overcast. It's going to be 50. Thanks for asking. Hopefully you guys are all having some okay weather and you're allowed to still get outside. We do have a stay at home from the governor of Illinois. So my wife and I have been in the house for like 3 weeks, both working from home. But we've been getting outside, getting our walks in and everything. So hopefully you guys are staying healthy and staying sane. Awesome. Anyone else have any questions? Or else I'm going to move on and move to the sheet metal parts. I think this is everything that I wanted to show. One more thing. This is kind of it was kind of annoying me. Like I couldn't rotate this part over. I'm trying to like move my mouse up and I can't rotate it. So there's a really cool setting. I forget when we added this, 2015 or something. So let's say I want to show off this model like I did in my GIF for the tweet that I did. Okay, nice. I'm kind of rotating it, and it's rotating about the scene floor. So if you right-click, there is a checkbox option, rotate about scene floor. It's kind of sticky in your system options there. So that looks nice. If I turn that off and I start to rotate, right, then you start to get that. And of course, when you're showing someone else your model or showing SOLIDWORKS to someone else, it's easy to kind of get crazy with the mouse and people get motion sickness. So I like to have that on kind of when I'm at my top level assembly and I'm just showing it off. Nice, smooth. But it kind of gets annoying sometimes because I want to rotate this thing over, right click, turn that off. So just know that that option is there and then you kind of get that full degree of freedom. Let's apply a material, might as well. Let's do an aluminum, and I do have it black FDM on this print. So let's go ahead and apply an appearance and let's see how close we can get this. It's a low gloss black plastic, apply it to the body. It's not too bad. A little isometric view, and what do you guys think? Not too bad. It's GIF, not GIF. Well, thanks, South TTM. I don't know what that means. Katia has a better rotation system. We're big cutting shape. Tell us about the feature tree arrows. Tell me what you mean, Stuart. Arrows just, mean that there's stuff you can extend. So, I got the tree up here. Favorites, I stored things in there. History's nice. It'll kind of show you what you've edited last. It doesn't necessarily keep a track of what you've done to the feature, but it just shows you what you've edited. Good. Reshab, good question. How is this thing manufactured? Well, this was FDM printed. The idea was this would be machined aluminum. Again, it's a premium mount. And it's meant to withstand some pretty big stresses, so of a 150-pound monitor. So FDM, I guess you could injection mold it if you added some, like a glass filled and you added some draft, but I didn't add that on here. So, all right, I'm gonna go. You guys know if you have any other questions. Looks like blue arrows showing up with the feature. Oh, yeah, the arrow. Oh, thank you. Yeah, the arrow's in the tree. Yes, thank you for clarifying that. So when I mouse over something, I'll zoom in so you can see it. Hover over for a few seconds, and you have the dynamic reference visualization system. I don't know what we call it. Dynamic references. And what it's showing me is what are the children and what are the derivative features. And that's really helpful to know, before I modify something, for example, if it's going to impact downstream features or where they were built on upstream. Kind of neat, huh? So you can turn that on and off at the top. If that kind of gets annoying, you can turn that in the tree display. You can turn that on and off. Or somewhere in here. I don't know. I've always kept them on. Some people find them annoying. Hey. Different strokes for different folks. All right, good. About halfway through this session, I'm going to take a couple seconds here, get a coffee, and then I'm going to go over to this red piece over here. Sheet metal. And we'll talk about a few tips and tricks for sheet metal design. Let me know if you guys are following along in the chat. Anyone trying to follow along? On a scale of 1 to 10, how easy do you think this would have been to model? I'm interested to see what you guys think of this. Simple, but again, capturing the design intent is what it's really all about. You can hack and slash any shape together, which is great, I think, for a preliminary prototype model like this. But then when you think about modeling it and the robustness of it, you want to build features in a way that you can go in and use Instant 3D and, you know, make some tweaks to it all and have it be able to update. All right, thanks, guys. I appreciate it. And 15, thanks, Stuart. You guys are too kind. Or unless 10 is easy. Then I have it backwards. Hopefully you guys learned a few tricks. You know, as I went through this, there was a couple things I really wanted to make sure you guys saw. You know, hiding and showing primary planes, using the heads-up view toolbar to turn those on and off, using auto scale in first dimension, sketch contours, shared sketch, the flat tree view, offset entities, offset in an extrude boss or an extrude cut, using the fillet selection manager, the whole wizard with a 3D sketch, using favorites, using instant 3D, using mouse gestures, using S key. I don't know what else I could do for you. Cool. All right. I'm going to start a new part. So going back to my assembly. Again, this arm used once, mirrored over. You can see I have the hardware in this final assembly. By the way, I'll put this final assembly up on our SOLIDWORKS forum so you guys can download it and play with it, do whatever the heck you want with it. Yeah, I think it's a pretty fun design. Try and assemble it yourself. It's always fun. Take all your mates, delete them all, and put this thing together. It's like a bucket of virtual Legos. Okay, so this red piece interfaces with the monitor mount, or the monitor itself with the VISA pattern. And if I look at the design intent here, I just Googled the VISA mounting pattern. There's a ton of them. So what I want to make sure is that this is maybe scalable and flexible enough to handle the biggest of the monitors. Again, the goal of this design was originally to be all aluminum and support a 150-pound touchscreen in such a way that you could mount this rigidly and then be able to rotate it, twist it, all these degrees of freedom, kind of in like a live designer view or another kind of large touchscreen format. So if I look at the VISA standard for larger monitors, there's a 200 by 100 that's less than 50 pounds, but the big boy standard uses M6 or M8 fasteners, and it's in 200 millimeter increments. So when I look at kind of my primary design goal, it's, you know, a strong enough bracket that can interface 200 millimeter increments and bring it back, take the stress all the way through here down to these aluminum arms. And all the way back here. And you guys can imagine the moment that occurs at this back mounting plate. I think that's probably the weakest point of our design, Brad, was back here when we conceptualized this. Anywho, let's start a brand new part and make this sheet metal piece. So, new part. Let's make it again millimeters. Appreciate the international crowd. Plus, it's a 200 millimeter VISA mount. So, let's do that. Let's turn on our primary planes and decide which way I want to model this. Now, I definitely want it to be vertical when I'm looking at it in isometric mode. So, I'm probably going to start sketching on my front plane and do my main interface contour. It's front plane, start a new sketch, turn off those planes. Sheet metal, we're only going to draw the contour, and then we're going to let SOLIDWORKS add the thickness. So one thing I really like to do for a sheet metal part to create that initial base flange is to do the midpoint line. That's a new feature, 2015, 2014. I don't know. It all blurs together. I've been using SOLIDWORKS myself since college in 2001. Actually, I found the book the other day, and it gave me nightmares because it was seemingly simple design of a pizza cutter. I just had no idea what I was doing. So hopefully I'm giving you guys some tips that'll help you get started. By the way, in the chat, let me know how long have you been using SOLIDWORKS? From never to 25 years, 26 years? Let me know in the chat. I'm really eager to hear. All right, so midpoint line. Going to give me that symmetry that I'm looking for. I'm going to snap vertical. Easy enough, right? And you don't have to do this, but I figure I'd show it. It's not that complicated of a shape. But since I am going to be symmetrical top and bottom, I'm going to use dynamic mirror entities about my horizontal center line here. You can see that turn on. And that'll just help me capture these arms here, right? You can see it mirror down. And notice those sketch relationships, that little box with the 45 degree, that's a symmetry relationship. Now, I have a 200 millimeter spacing. So I'm going to put a point at the midpoint of each of these. And then the first dimension I place, oops, get the point to point, is going to be oh, look at that. Hey, 200 millimeters, it's 198.87. That's close enough. Remember, this is cool. So the first dimension I put down, let's say it was 2000, it wouldn't matter. It scales everything to that first dimension. And we'll throw in a couple more design dimensions. And an angle here. And how about a width? 40. And it should be fully defined. Again, I'm always kind of looking down here at the bottom right, fully defined, to see what I have going on. All right, 2 years, 3 years, 8 years, 1 year, 3 years. Eric Beatty, what's up, man? Yes, you are pro. Stuart, 18. Thanks, guys. There's a little delay in the chat, so I'm just kind of looking at your answers now. Eyeballed it. Thanks, Hackneo. Nice name. I love that. So I'm fully defined. And notice I didn't put the rounds. And that's the thing. With sheet metal, SOLIDWORKS is going to take care of the design intent. Because I don't know the radius of the 2 bends, well, 4 bends yet, because I don't know what gauge it's going to be. And for manufacturability, your bend radii is going to change based on your gauge and your tooling. So when I create the base flange, you'll notice SOLIDWORKS is automatically applying the radius for me. Right? It's just taking that edge, and it's kind of like what we just saw. It's making a thin feature for me, right? And this is just like an extrude thin feature, except on the left-hand side, since I use the sheet metal base flange, it's giving me sheet metal design intent. So, for example, let's do a mid-plane 250 for now. And instead of giving it a thickness value, I'm going to use a gauge table. So there's some example gauge tables, and there's a bunch of great tech tips and articles out there on how to create a gauge table. But the bottom line is it lets you put into an Excel format what gauges of sheet metal I want to use, and then what the bend radius is. So if you think about if you're in a manufacturing situation, you probably have a standard stock with different materials, and those stocks based on your bending equipment has different bend radii. And you can capture all that stuff right here, as well as different bend allowances. Anyway, I don't understand it that well. You guys can Google bend allowances and all that. Sheet metal is a whole science. I don't pretend to be an expert on it. So let me pick a simple aluminum metric sample table. 1999, 3 months. Hey, Spring Bounce, 3 months. What's up, Puckett? Regnaris. All right, there we go. Mid-plane. Notice the thickness is going in. I actually want it to go out for my design intent so we can reverse the direction. And there we go. So 10 gauge seems a little thick. I think the original design I'm looking at here was more of like a 16 gauge. Again, I don't really know what the best gauge is. 150 pounds. I'm going to have to run a quick simulation. We probably won't have time for that, although I love a simulation. But that can help me answer, how thick this needs to be. Let's just eyeball it. 14 gauge seems about right. Yeah, easy enough, right? Save this thing. Interface, arm. And I'll throw it on the desktop with all my other very important files. Now, hopefully you guys are using a little bit better system, like a PDM or an InnovioWorks system to save your files and share them between each other. Again, I want you to notice this. How many times are you going normal to the screen or trying to get normal to your sketch? So again, set up your mouse gesture for a comfortable way. All my mouse down gestures, give me that normal to. S key, bring up my sketch tools. S key, bring up my dimension. Just throw some design dimensions on here. And let's cut through, and I'm going to link this to the thickness. Again, once you're in sheet metal mode, you see a few purpose-built tools. Link to thickness is kind of like through all, but it's going to always be through that one sheet metal thickness. So if you have other sheet metal or you create some other bends behind it, it won't take that out. So on the back here are where the arms, I'll show you guys the model real quick. On the back, you can see the red piece. They come out, and there's kind of a pivot point with those knobs. And then it also has the I forget what the fastener is, but the one fastener that connects it to the intermediate bracket. So I'm going to use an edge flange tool. Again, I kind of have my S key set up here with some different SOLIDWORKS sheet metal tools. Let's do an S key. I'm going to grab that. Show you that again. S key, edge flange. And it's grabbing the edge, and it's going to automatically create for me a radii bend with the same thickness going in the direction that I want. So for manufacturability, though, this would be a little bit tough. Let me show you what it looks like by default. That's going to be tough to get in there. So there's a bunch of options in the edge flange that you can modify. For example, the flange position, we can move that to outside. And then I'm also going to edit the flange profile. Brings up that sketch that it's doing for me automatically. And let's just move that down. Give this a little bit of a clearance. Let's say a 1 millimeter clearance. That should be a little bit easier to cut out. What do you think, Eric? You know manufacturing. Does this help you a little bit? 1 millimeter. There we go. Easy enough. Edge flange, front plane, and let's mirror that. Features, mirror. There we go. All right. I want to kind of create this arc cut through all of them. So I'm going to go on my front plane. Sorry, I was thinking about my last model. Mouse gesture down, normal 2. And let's just create a circle to cut that out. All right, so my circle, I want to define it, even though I'm just using it as a cutting tool. Let's define it. This is really nice. If I control select the origin and that point, I always get this messed up. I want those to be like horizontally aligned, but is that a horizontal alignment? Is it a vertical alignment? I don't know when SOLIDWORKS started doing this, but it kind of hints to me like, hey, that's horizontal. You're closer to horizontal than vertical. So think about how many times you mispick that. Yay, horizontal. Throw in a little driving dimension. A little radii. There we go. Okay. Extrude cut. Through both directions. Mouse gesture. Okay. Got a lot of sharp edges on this thing. I'm going to use the break edges tool in sheet metal. S key, break edges, break corner, if you will. I'm just going to mouse select basically the whole model. Windows select everything there. Boom. Add a little rounded edge. Let's give it a little bit bigger radius. There we go. All right. And how about the slots now? Remember, we need some clearance slots for M8 fasteners at the right distance. So I'm going to pre-select this face and then go into the hole wizard. And remember, if I don't pre-select, what happens? 3D sketch. If I pre-select, 2D sketch on that face. There we go. Normal 2. Again, take that time, set up your mouse gesture. I use that so often, becomes second nature. Into the hole types, you guys know hole wizard. You saw me use it for the counterbore fasteners for the arm. Here I'm going to use the slot tool. All right, and I'm going to do an ANSI metric screw clearance for my M8. Heck yeah, check that out. How cool is that? Position my slot, position my slot. I'm going to grab a center line. And a lot of ways to dimension this, but here's how I'm going to do it. Center line to center line. Grab that in the midpoint of the slot. Grab this. SOLIDWORKS says, hey, you're almost horizontal or vertical. I get it mixed up. Vertical. There we go. Right click on this line, select midpoint. When I have that selected, I'll hit or hold control with my little pinky. Grab the origin, make those coincident. And then we know my design intent is to have the center of these slots be 200 millimeters, and you can see they're centered by virtue of the fact that that center line connects it. I love that select midpoint. I'll show you that here in a second as well. So I'm going to do one hole. That should be good. And then I'm going to pattern it. Reason being is because I might want to change the spacing later, so I don't want to kind of bake it into that absorbed hole wizard sketch. What I want to do is do a linear feature pattern and grab it. So let's do our linear pattern. First direction will be this way. Other direction is going to be that way. Features and faces, you can grab it from the tree, you can grab it from the graphics area. I want to make sure that I grab the hole wizard feature. So I'm going to grab it right here from the tree. Hey guys, yeah, resolution, sorry about that. I might have some internet slowdown. I'm at 1920 by 1080, so I can't go any slower. Can you turn the slot about a specific design? Yes, in the slot, you know, if you think about the hole wizard, it's defined by a point usually, but with the slot, there's a little horizontal line as well that's built into it that you could turn. All right, so let's pattern this thing, and it's going to be 100 millimeter spacing one way and 100 millimeter spacing the other way. All right, and this is a good example of where you want to use the option to pattern seed only, because typically in a linear pattern, what SOLIDWORKS is going to do is take your feature, in this case this slot, and pattern it the one way, and then direction 2, it's going to take that whole set of what you patterned and go the other way. Now, if I did this here because they're parallel, it's basically going to double cut through that center hole, triple cut even. I don't even know. We don't want to do that. So pattern seed only just takes it and patterns it this way, and then independently patterns it this way. Okay, so you can play around with that. If you just have a plate and you put a hole and you pattern it vertically and horizontally, and you do seed only, it'll just do a row and then a row. Uncheck that seed only, and it's going to do the row and then pattern that all down. I don't know if that made sense. Try it out and know that that option is there. And actually what I want to do is have more than that, but let's do this first. Okay, so this actually gets me this size bracket. Easy enough, right? With the 200 spacing in these outer brackets. I want it to be a little bit longer though. Some of those monitors actually have 3 sets or 4 sets or more, 5 sets. So I'm going to take my Instant 3D, drag this bad boy out a little bit. And there I can pick up that next pattern that I didn't have enough material to cut through. Pretty cool, huh? So that's how we originally designed this thing, and then I sent it off to our friends at Go Engineer to have it printed. They're like, we're not going to print you that long version. And they made me this short version, but thank you for all that help years ago getting this thing prototyped. But yeah, a lot of material there on the long version. All right. So now I want to get this thing, let's say I'm ready to go to manufacturing, and not just the FDM prototype, but I want to create a actual flat pattern. So the thing about sheet metal is if you do sheet metal from the beginning, or you convert to sheet metal, or you import and recognize sheet metal features, when you have this sheet metal, it kind of gives you the magic ability to have the flat pattern. Flatten this thing out, and there we go. And you can see here why I did those 1 millimeter cuts. And there's my flat. So better yet, I want to export this to someone like Eric so he can cut this out for me. I'm going to right click on the flat pattern and export to a DXF DWG, 2D drawing. Put it on my desktop with everything else important. And what do I want? I want the sheet metal features. I want the geometry. I want bend lines. Forming tools, and my output alignment. Let's just center it all on my origin. And so this is basically your fast track way. Without having to go to a drawing and make the drawing views, you can quickly export the DXF DWG. And then depending on what you want to include in that actual line art, you can take these entities out or not. You can see the bend lines are these dashed lines, but let's say I don't want that. That'll mess up my cutter. So you can go in here and kind of clean this up real time before you actually save the file. And now I just have that flat that I can send out. Easy enough. Oh, I did want to show you guys something else. This is really cool. On the model, we added some structural and kind of cosmetic too gussets. So a gusset kind of makes an indentation for me automatically without having to use a forming tool. So check this out. I'm in the sheet metal gusset tool, and let's position it by selecting the midpoint on the line there. Pretty cool, right? Let's do another one. Sheet metal gusset, edge. For the point, right click, select midpoint, boom. Okay, awesome. And another great example where if I go into my flat pattern, export that DXF, I probably want to delete the outline of those forming tools. Now, when you think about making a drawing of this, let's say you have to make a drawing, you know, more of a controlled release document. We can make the drawing from a part. And it's a real good idea to set up some templates that are maybe specific to the different types of manufacturing you're going to use. So this is a sheet metal template. It has a few notes on here that you know you're going to be putting on like every sheet metal part. You could also have predefined views like the flat pattern. But let's just use the drawing palette, the view palette on the right-hand side here, and let's drag on some of the standard views. So let's drag in my right view. And let's right click and add a projected view, top view, side view, and drag an isometric view, and then drag a flat pattern in there as well. All right. Now my sheet scale is 1 to 8. Let's actually bump that up. 1 to 2, that's a little big. Let's go to my sheet properties and make that, maybe 1 to 4. There we go, that looks good. Take my isometric view, maybe we can shade that so my printer uses a lot of ink. And then my flat pattern, I might want that 1 to 1. So overall my sheet scale is 1 to 4, but my flat pattern over here, let's use a custom scale and make that 1 to 1. And then it's pretty big here, right? So what I'm gonna do is add a second sheet, a blank sheet. And I'm just gonna take this view, Control X, oops. Let me copy it actually. Control C to copy, sheet 2, Control V. I should have picked a better sheet format, but you can move it to the second sheet and make that a 1 to 1. The other thing I wanted to show you guys, let me make this smaller now, but if you need to get real size, you know, that's how you can adjust it per view. There's a couple other outputs you can do on your sheet metal piece. For example, you can see the text starts to get kind of crazy. It's crowded. As you have more and more bends, it'll get a lot more crowded. So we're going to insert a table, a bend table. And that'll replace all the text with the direction of my bends with just a little reference. Clean that up a little bit. And I have a cute little table that shows me the radius, angle, and direction of each of the bends. There we go. Save this thing. Yes, save it on the desktop. Stuart, yeah, you can read that. Eric, yeah, man, I'll take you up on that. I got the 3D print, but I should totally do it with a real sheet metal. I always wanted to create this model, but as you can see, we printed it out and then realized, I actually tried to put some weight on here, and this back bracket at the moment is just so heavy. And that's why when you see, obviously, these real wall mounts, they have huge vertical bars, don't they, to counteract that moment. Because you can imagine you have this thing all the way out and 150 pounds on there and just the bending moment. So I kind of tore it out of my wall when I put this thing on there. Still looks cool though. So I need a little bit more engineering. By the way, since we have a couple more seconds, check this out. So how well would this survive the weight? Let me open this up here. I think I have a simulation study. I did. I set up a static study. So you guys all have simulation. Even if you don't have like this real simulation tool, you all have Simulation Express. And you can run what we call linear static analysis here. So I've set up some force. Actually had 100 pounds here. Let's make this 150 pounds. And I'm curious to see if this is going to be thick enough. And I've rigidly restrained it with some roller slidings and some fixed kind of anchor supports in the back. I define it as 1060. And let's run this thing and see what our factor of safety is, right? Does the stress that results from that distributed 150-pound load exceed the yield strength of the material? And that's kind of what your fundamental linear static analysis shows. Displacement, stress, factor of safety. Guys, didn't know you're going to get into some simulation, huh? Any simulation users? Let me know in the chat with an FEA if you guys are sim users. I love this stuff. You get look at these pretty pictures. So here's my stress plot, your von Mises stress. Let's look at our displacement. And by the way, this is magnified 35 times. I'll show you the animation. And you can see here, kind of checking my assumptions now. Would it really be that rigid when you look at the whole system? Well, I did let it rotate a little bit with the roller sliding restraint, but if I was really doing this analysis, I'd want to go and do the whole system, right? I'd want to back up and make sure that I do a simulation that transmits through the fasteners, through this pin, down the arms, and I'm kind of restraining it at a more rigid spot. So keep that in mind when you do analysis. Single parts are cool, but usually it tends to be over rigid because at some point you're saying this is infinitely rigid with that restraint. So add in more parts before you get to that hard restraint. So it looks pretty cool. Let's do a factor of safety plot on this thing, which will actually do that calculation for me of yield strength to maximum stress. And let's do a defined minimum value of 1, max of 10. And you can see here, there's a lot of area here that's under bending. So why don't we pick a different material real quick? Let's apply a 6061 instead, T6. Get a little bit more aircraft grade. By the way, that's my background, aerospace engineering and stress analysis. So of course I'm going to use this time to show you guys simulation. Anyway, let me know in the chat if you guys have any questions as we wrap up between these parts, the machined arm or the interface bracket. Okay, so now check this out. I turned it to 6061 T6 and my factor of safety. Look at that. Oh, I did a different relief on this one. This is the other one I modeled because I already had my simulation set up on that one. But yeah, you can see I'm getting these stress concentrations here. And right where I rigidly restrained it, I'm getting the highest concentration. So again, that may or may not be real stress. You really want to include that next layer of components to find out. Cool, huh? If you guys want, I actually did a more advanced simulation in this video. This is called Concept Before CAD episode 4, where Brad Williamson and I actually went through and did the concept model on the 3D Experience platform. Then we brought it into SOLIDWORKS to do the final design. Then we took it back into SimuliaWorks to do a dynamic analysis. Because what we wanted to understand is, you know, worst case, you move this arm and the 150 pounds oscillates because you had an actuator that was raising it up and down. What was the dynamic response? What was the dynamic stress? Because you think about it, static is staying still, and dynamic, you can see you might have an inertial response. Anyway, you guys can Google this on YouTube if you want, Concept Before CAD. Pretty fun. Anyway, we ended up finding here, this was the weak spot of that design. So to wrap this thing up, I guess that's where engineering and design are a little bit different, aren't they? Is that design is all about getting your shape and your design intent and manufacturability, and then engineering got to go through and make sure that this is going to work from a factor of safety standpoint, from a systems standpoint, and this is really where the weak point of the design was. But that being said, I hope you guys learned a lot today, you know, through these two different parts. I hope you guys watched the recording, follow along. Definitely hit like if this was good, and come back for our next live stream. On Monday, Andy Barnes is going to be doing a really awesome industrial design of a snowboard and ski wax iron. So you can actually set a reminder right now on our channel to get notified when that stream comes on. It's going to be Monday, same time, 1 p.m. Eastern. We don't have time for questions. If you have questions, put them in the comments and I'll make sure and watch those. Or else they're also having a thread in our SOLIDWORKS forum to continue the discussion. So come back Monday for Andy. Check it out. Thank you so much for watching, everyone. And see you next time. Bye.